No voice? No voice today? I'd be doing better if I heard from people. Wyatt popped in and popped out a second ago. We got about 5 minutes, and then we'll go ahead and get started, okay? Or you have any questions I can help you with right now? We were going to start with set B and then going. Is that you, Logan? Sorry, my screen's way over there, so if I turn, I'm looking at you. Logan, no going to sleep. Got to wake up, my friend. If I turn to the side and look over there, I'm just looking at you guys. Logan, you got any questions? I'm going to start the morning with questions on set C, or set B, excuse me. Then we'll go over some probability stuff and we'll move on. I'd much rather you guys were here, frankly.
I don't know, it's pretty cozy over here.
Yeah? Comfortable and wrapped up in that blanket?
Got a Mickey controller over here, dude.
There you go. Those are nice, yeah? Well, I don't care if you warm up Hot Pockets right now and eat them during class.
Oh, it's so cool. I'm so excited.
Have refreshments there. Who's that now? Lexi. Good to have you here, Lexi. We're going to give it about 3 minutes, and then I'll really start up. If you guys got questions on set B, remember A and B are due today. So this is what you should have already done this kind of stuff.
I'm just confused on set A and B.
Yeah?
I'm sure I'm just slow.
We went over set A. Well, let's look, Logan, let's just go ahead and start right now on set B. Here it is right in front of us. Yeah, grab that and we can start up on some questions. Then we'll get into set C and set D.
Sounds good.
Greetings, Casey.
Do a monitor for the campus. Cool kid.
If you guys could turn on your cameras, that would be great so I can see. Unless, of course, you're not don't feel like you look good enough or whatever. I'm sure you all look wonderful, but whatever. If you're not comfortable with it, don't worry about it. Logan was just saying he's a little confused on set B, so I wanted to look at some questions on set B, and then we'll go over set C and set D. Okie doke. So we're about ready to start. Logan, do you have things on set B you'd like to look at, or just want to randomly pick a few things?
Let's just randomly go through it.
Okay. And I'm going to continually be looking over my shoulder over there. That's because my screen's way over there. Anyway, I haven't got it. Anyway, enough of that. Okay. Then let's look at this. Let's just pick a couple out of that one. This first one says you're picking a number between 1 and 50. Find the probability of each thing. All of this, you know, they're going to be probability of whatever. You know it's going to be out of 50. An even number, a perfect square, a factor of 150, a two-digit number, a multiple of 4, numbers less than 35, a prime number, a perfect cube. Okay, all of those are just out of the entire group, so they're always going to be over 50 here. This is just basic probability, like you learned way back in elementary school. You've just got to count the number of things in this event. For example, even numbers. How many of the numbers from 1 to 50 are even? Who else do I got around here? I see Alondra there, Lillian, and Kaylee. Awesome. Good to see your faces, guys. Wonderful to see y'all. Welcome to class. We're just looking at some questions off set B. So even numbers. How many numbers are even between 1 and 50?
24.
24? Wouldn't it be 25?
25.
Yeah, because Half of them are odd. A number is either even or odd, right? Half of them are even, half of them are odd. And so 25 out of 50 are going to be there. Okay? But when you get to things like two-digit numbers, how many two-digit numbers are there? A prime number. This was something that I've worked with a couple of people. Prime numbers. What are my prime numbers between 1 and 50? This you're going to have to list out. Or, you could do a Google search of what are my prime numbers. A prime number, remember, is a number that's only divisible by 1 and by itself. So, like 1 is prime, 2, 3, 5, 7, 8, 9, 10, 11 is prime, 12, 13. What?
There's 15 before 50.
So it's going to be 15 out of 50. Okay? I don't care whether you reduce that fraction or you leave it as a percent or you change it to a decimal. It's all the same. When you're finding probability, I don't care what you do with the final number. You can leave it like that. I would leave it like that just because I'm lazy and I don't want to do more than I need to. Okie doke. Okay. If I'm looking at this stuff, 2, I'm randomly choosing 2 marbles. So I'm choosing 2 marbles. Remember, when you're choosing 2 things, you're going to be multiplying the probability of the first thing times the probability of the second thing. That's how you do multiple things. You multiply their probabilities. That was one of the big ideas we looked at last time. So if I'm looking at marbles, randomly choose 2 marbles, replacing the first marble before drawing again from a bag containing 10 black, 8 red, 4 white, and 6 blue. That's 10 plus 8 plus 4, 18, 22, 28. So there's 28 total marbles there. Find the probability of each of the following events. And the first one says a white marble and then a red marble. Well, a white marble, you've got 4 white out of the 28. And then it says, and then a red marble times a red marble. Red marble, there's 8 red out of 28. So 8 over 28. And I would multiply those probabilities. Now, I'm getting a calculator for a second. Okay. If I get a calculator for a moment, 4 over 28 times 8 over 28. And I guess I could just reduce these, but I don't want. I'm just going to use a calculator. And I get 2 over 49 as a fraction, or 0.04. I'll round it to 3 places, 0.041. The big idea is if you have the probability of 2 things and you're trying to find the probability of both of them happening, you multiply the first probability times the second probability. That's what all of these are about. Okay? On this, number 3, this is all about, like we did in class, finding the probability given a whole sample space. So I've got a bunch of cards here, it says, and I'm drawing a card from this pile, and I'm trying to find the probability the card is even or shaded. Well, even or shaded. Well, there are there are 10 cards there. So 3A, the probability, I can just do it here. Problem if even or shaded, it's going to be something over 10. How many of these cards are even or they're shaded? Well, I'm going to pick out each card. This card, it's shaded. So I'm just going to make a tally chart here. There's one. This card, it's even and it's shaded, so I'll count it. Not even or shaded, that's even. So that's going to be there. That's not even or shaded. This is even, so that's going to be there. This is not even or shaded. That's even, so that'll be there. That's shaded and that's shaded. So there are 1, 2, 3, 4, 5. Did I count? There's 1, 2, 3, 4, 5, 6. Yeah, 7. 1, 2, 3, 4, 5, 6, 7. There's 7 out of these 10 cards that are even or shaded. The simplest way to look at probability, guys, is to have the whole sample space out in front of you and just count. Okay? That's kind of what this assignment is about on set B. Okay? That's kind of a crash course on it. Does anybody else have any specific questions on set B Or can we go on to set C? You guys are never this silent in the classroom. What's going on? Okay. If you're awake, wave. There we go. I can see half of y'all. The others, I can't see you. Okay, guys. Thanks for joining me. First of all, for those of you that just came in, we've got what? Sorry, I'm walking over. I can't read that far away my screen. I need to move it. Max, good to see you, my friend. You got your headphones and other stuff's on. So you can talk. Angelina, good to see you. Glad you found some good access. Cohen, nice to see you, my friend. Glad to have you here. Haley, nice to see you. The other Cohen, great. Annalisa, great. Macy, wonderful. Glad you're able to join us. Kaylee, Alessandra, Lillian, Caden, Ben. Oh, Ben, nice to have you here. Ben is new. I look forward to meeting you, Ben, when I see you again. Now, Ben, was it you or your mom or somebody that I've been messaging back and forth for the last yesterday? Ben, was that you or one of your parents that I was texting back and that we were messaging back and forth on Canvas? Too shy? Okay. Then, guys, what I want to do first of all is just remind you of something. So I'm going to pull up Canvas here in a sec for just a second. Okay, just remind you. Oh, I don't want to do that. You can see this isn't much different than being around here. I'm going to klutz here too. Okay. On Canvas, guys, a couple of things I added for these few days. There's a couple of things here. Remote classroom link, you can find it right there on Canvas. Also, the schedule online help, you can find it right there. Hold on, I got to get back to something over here. There we go. So if you click here to schedule that online help, that opens up appointment slots in the afternoon. You're welcome to if you want to get some one-on-one help, or you just want to hang out and have a 15-minute conversation with me. If that's the case, prioritize things in your life a little better. Anyway, you can click on that. Now, if you go to your modules, remember this is where we're at. R and S and U and V, these are closed. They're not available anymore. Okay? Now, sets A and B, they are due today. Guys, get them turned in. The picture upload link, I apologize. I realized that wasn't there until this morning. I just put it up. So snap a picture and send it in there. Okay? So there's the homework quiz that you enter answers with. Here's the picture upload. Your assignment, if you haven't gotten it yet, A and B are right here in the homework sets. Okay? So you open up the homework sets and they're all there. If you need more help than that, there's more notes, and here's some video aids specific to set A and B. Okay? So get that stuff in. That's the homework that is due. Today, we are looking at sets C and D, and then you have your first quiz of the quarter. This is due by January 24th. Okay? It will go in as a 0 after that. Remember, that's a big chunk of your grade, so don't skip it. Also, remember, you can take that quiz multiple times. You can take it as many times as you want. If you get a bad score, take it again. If you get a bad score again, take it again. If you get a bad score a couple times in a row, stop, come and talk to me, and let's work through things, and then take it again. There's no excuse for that, okay? But set C and D where we're looking at. Okay, so the homework sets are here. The notes are here. Here's some video guides. So you can get it there. But let me tell you what it's about. Any questions on what the expectations are? A and B are due today. C and B are due for y'all on Friday. And then when you come back on Tuesday, If you haven't yet, we'll take the quiz. I'll give you a few minutes to take the quiz in class that day, and then you can retake it if you need to. Any questions on any of that? Just kind of housekeeping protocol items for a little bit? No go? Okay. Then what we want to look at is we're going to look at some probability. We're looking at mostly and probabilities today. The probability of two things happening. So we know we're going to be multiplying. But everything you dealt with on set B were called independent events. Independent events is where one thing does not affect another. So, for example, if I flip two coins, one coin doesn't affect the other's flip. Okay? If I draw marbles and I replace them every time I pull it out, those are independent. The first marble doesn't affect the other one. These are called independent events. If I have two events that are independent, so I'll call those events A and B, are independent, then the probability of both of them happening is equal to the probability of the first one times the probability of the second one. That's kind of what we were doing in set B, when we're just finding the probability of a black marble and then a red marble, and then we're multiplying them. All of those were independent events. What we're looking at today is, what about events that are not independent, where one thing affects the other? Okay? I want to skip this for a second. We're looking at dependent events, where one affects the other. Let me give you some examples. If I'm drawing two cards from a deck of cards, if I want to find, say, what's the probability of getting a pair of aces? Well, I draw the first card off. Now the whole number of cards in its stack has changed, and the number of aces has changed. So the probability changes from the first card to the second card. Okay? Those are examples of dependent events, or some other dependent events. Drawing two cards is dependent events. If my mind's gone blank for a second. So dependent events, I'm sorry, and we're shorter on time too. Dependent events are one does affect. Let me show you some things for examples. Okay, if I have a jar, containing 10 blue balls and 11 red balls, probability, we like to keep things simple when we can. We'll talk about balls and marbles and coins and all that stuff. So how many balls are total in this jar now? A jar contains 10 blue and 11 red. So that means there's 21 total, right? Okay. 2 balls are drawn out without replacement. So that means the first ball, I pull it out. Now how many balls are left? 20. Okay. Hey guys, talk back at me. It helps me feel like I'm not alone in this big empty room. Thank you, Logan. With my dead fish tank over here. Maybe I'll take one of these afternoons on this soft closure and actually clean that thing out.
Good idea.
Anybody like that idea? I like that idea. So you don't have to look that grungy. Okay. Aurora likes that idea. Aurora, what kind of fish should I get? Can't hear you. Koi? Koi get like, carp get freaky big. You think I can fit that over there? Why don't I just get rainbow trout and then we can go fishing every day and cook it up for lunch?
You can just get some beta fish.
Some beta fish, like more than one, and watch them fight and kill each other?
Yeah.
That'll be like fifth period all over again.
Literally zero knowledge about fish in my brain.
A sturgeon. Sturgeon are actually a protected species in the state of Utah. They're considered an invasive. You can't bring them in. They're ugly looking fish too. If you have suggestions, tell me. I'm going to do that, guys. One of these afternoons this week, I'm going to take that fish tank. I'm going to clean it out. And when y'all come back next week, there'll be like clean water and fish in it.
Perfect.
Wonderful. You're not near as excited as I am, guys. Let's talk about balls and jars. That sounds, I don't know. Okay, 2 balls are drawn out without replacement. What is the probability of getting 2 red balls? Well, if you're going to get 2 red balls, the first ball had to be red and the second had to be red. Can you see that? Guys, when we're talking about probability, oftentimes it's difficult to split things into 2 different events. But when you're talking about 2 red balls, that's 2 different things happening. So the probability the first one is red. We've got 10 blue and 11 red. So the probability the first one is red is 11 out of 21. What's the probability the second one's red? Well, how many red balls are now in the jar?
It's 10 out of 21.
10 out. No, it's not.
Yeah, it is.
No, it's not. It's 10 out of 20.
10 out of 20.
See how that changes? There's now, I pull a red ball out. There's only 20 balls left in the jar, and only 10 of them are red. This is a dependent probability because this first one changes this second one. So to find the probability of 2 things happening when they're dependent, you're still going to multiply them. You multiply the probability of the first one, and you multiply this. This is called a conditional probability. This assumes this one happened. Let me show you this. This is the probability that the first is red. That's what this probability is right here. This probability is the probability that the second is red, given. That line is a given. Guys, in your notes, write down this notation. By the way, I'm recording this screen, not your faces, but this screen. So, and I'm going to dump that on Canvas here in a little bit when I get done with this. So you can watch this whole thing over and over and over again. Put it on a loop, and it'll put you to sleep at night maybe. Okay, this is the probability. This one is the probability the second is red, given that the first is red. This right here, we call a conditional probability. Conditional probability. Because it's the probability of the second one, but it has a condition on it. It assumes that the first one happened. Okay? 11, I don't know what that is. 11 times 10 is 110. 21 times 20 is 420. I'm not sure what that is. I'm going to go in my calculator. 11 over 20. What is it?
11 over 42.
Yeah? Oh, yeah, because you just cross out the zeros. Duh. I see that now. I'm feeling it. Or 0.26 if I round it. If you're going to express it as decimals, go to at least 2 or 3 decimal places, okay? I'm not going to be too particular. I'm going to be looking for the work. If all I see is your answer, guys, on this, no go. Give me some work. The work is just going to be this kind of stuff, okay? So the big idea we're looking at today is to find the probability of 2 and things that are dependent on one another. You've got to think about the probability of the first one and the probability of the second one. The second one, you have to assume that the first one happened. Okay? And then we're just multiplying them. We good there? Questions on that? I want to look at a couple more things with you. Okay, so let's move on. Another situation, similar kind of idea. A drawer contains 7 blue, 3 black, and 6 red pens. So that's a total of 16 pens to start with. Okay, 3 pens are drawn out without replacement. What's the probability of getting 2 red pens and then a black pen? Okay, 3 pens are drawn without replacement. What is the probability of getting 2 red pens and then a blue pen? Okay, if I'm drawing 3 pens, I've got 3 things happening here, guys. So the probability of getting 2 red, so I want to find a red pen, and then a blue pen. So I'm going to describe that. A red pen, the probability the first one is red, there are 16 pens to pull out, and I see 6 of them are red. So that's going to be 6 out of 16. Now, if I pull a red pen out, what's the probability now the second one is red? Well, how many pens are left in the drawer? 15. And 5 of them are red. See how that's changing? Okay. The last one, there are only 14 pens left in the drawer, but the blue pen, how many are blue? 7. Each of these are conditional probabilities. This problem assumed that we pulled out 2 pens and they were both red. So all 7 blue ones are left and there's only 14 pens left. So we're still multiplying the probabilities. Easy way to think about this, guys, is split it into 3 different probabilities and then think about them one by one. And think about it. I pulled out a red pen, what's left? Okay, so if I multiply these, 6 out of 16 times 5 out of 15, this is where my calculator comes in handy because I don't want to do this in my head. 7 out of 14, I'm going to get 1/16. There's the probability. Or if I convert it to a decimal, 0.0625. Okay? That's the probability. This reminds me, guys, of... Oh, I don't want to do this. Not yet. Well, this isn't for you. This reminds me of putting socks on in the morning. You know why? I'm going to tell you why. I've got a sock drawer. My sock drawer, I know, has a bunch of black socks. I know I've got 7 pairs of black socks. I've got 7 pairs of white socks. These are my longer socks. These aren't on the short little socks that I wear when I have tennis shoes or go around in the summer. These are my longer socks. 7 pairs of white socks, but then I also have 4 pairs of brown socks. And I'm kind of boring. All my black socks are the exact same socks. All my white socks are the exact same socks. All my brown socks are the exact same socks. And I don't bother to pair them up or fold them, anything like that. You get to be an adult mom, and I don't care what my mom says anymore. I just dump them all in the drawer, and I pull out a couple of socks. But the problem is I get up early enough in the morning that my room is dark, and I don't want to turn on the lights to wake up my wife. So I just walk over to the drawer, and I feel around until I think I pulled out 2 socks that match, and I pull them out. And I put them on in the dark, and then I go to the front room, and sometimes I don't have socks that match. Have you ever seen me with socks that don't match? If you haven't looked at my feet, because that happens more times than you think. So let's think about this. What's the probability that I have a pair of socks on that don't match? It's actually going to be a lot easier to find a probability that they do match and then subtract it from 1. If I find the probability they do match, what I got to find is the probability that I pull out a pair of black socks. And then I got to find the probability that I pull out a pair of white socks. And then I got to find a probability that I pull out a pair of brown socks. And then if they match, they could have both been black or both been white or both been brown. So what I would do is I would add those together. But see, these are dependent probabilities. Let me show you. The probability I pull out a pair of black socks. Well, I've got 7 plus 4, that's 18. Yeah, that's 18 pairs. That makes 36 socks, because a pair is 2 socks. So the probability the first card someone is black is 14 out of 36 because I've got 7 pairs. That means there's 7 times 2 is 14. Times the probability the second one is black. Well, if the first one was black, there's only 13 blacks left. And there's 35 socks left in the drawer. Do the same thing with the white pair. We start over. The probability of the first one is white. Oh, hey, check this out. Since they're the same number of pairs of black socks and white socks, these are going to be the same. 14 white socks over 36 socks times 13 left. After I pull one white sock out, there's 13 left in the drawer, and there's only 35. And I'll add those together because I'm finding this or brown. Brown, it's still going to be over 36. 4 pairs of brown. Oh, that means there's only 8 brown socks in there. And if I pull one of them out, there's only 7 left out of 35. If I add all of this together, 14 out of 36 times 13 out of 35 plus the same thing again, plus 8 out of 36 times 7 out of 35, I get 1/3. So there's a 1/3 probability that I will pull out a pair of socks that matches. Well, the only other thing that left is having a pair of socks that doesn't match. So if I go 1 minus that 1/3, that gets me 2/3. So I have a 2/3 probability, or in terms of a percent, 67% probability that my socks will not match.
3 days out of 5, pretty much.
3 days out of 5. And this time of year, guys, it happens 2 or 3 days a week that I'm wearing a pair of socks that do not match. And you know what? Sometimes when I go downstairs and I notice, oh, my socks don't match, I say, oh, crud. And I go back upstairs and maybe I cheat and I get a light and I put it out and it wakes up my wife. She gets mad. Other times I'm like, yeah, I don't care. And I just come to school without matching socks. That happens. What?
Are you at the school right now?
I'm at the school right now.
So it's safe for you to be there, but not for us.
It's not the school. The school's not dangerous. You are. The idea is, well, let's think about this. Let's think about this. This is a game of probability for a second. Let's talk about it. The last number I heard yesterday, the confirmed thing, there were 54 positive cases of COVID, of active cases in the school. Okay. Now that may seem like not a lot, right? But figuring out probabilities is not always easy. I'm not going to explain all of this to you, but 55 cases of probability. If we 55, and I happen to know that they had 140 students test from Roy. We got these numbers from the health department yesterday. So out of the 140 people that tested, 55 had COVID. So 55 divided by 140, that gives me a 40% probability. That's consistent with the test rate that the state is showing, that about 40% of those people testing actually have COVID. Now, that's not going to say that 40% of the student body has COVID, because what's different about the people that go get tested as opposed to the general student body? What's different?
If you get tested, you're already suspicious of having COVID.
Yeah, you either know you've been exposed or you have symptoms. So I can't say that because 40% of the people that got tested have COVID, 40% of the student body have COVID. Okay? But if I take that 55 divided by the number of students that are attending every day, let's take that. If we just assume, hey, that's all the people in the school that have COVID, and I really don't believe that because I know numbers and we see what goes on in the news, right? But if we assume that, and every day there's about 300 kids that are absent, that's a lot. It's huge this year. That's about 1 out of 300 kids that have COVID. Okay, let's just assume that. If you have a room of 20 people, this is actually a probability that you can calculate. And there's a 1 in 300 chance that they might have COVID. What's the probability that what's the probability that you have, say, a couple of people in that room? What's the probability you have one person in that room that has COVID?
90,000, isn't it?
No, it's actually a lot more than that. This is what's called a binomial probability, and it's a lot more complicated than we have time to explain. But it ends up being that if there's this many COVID people in your school, the probability you have of having a COVID positive person in there, let me think. Sorry. It's actually about 2.4%. Okay. And then if you, what?
If it's 1 in 300, that's 0.33% for one person.
Yeah, for one person, but you got 20 people in the classroom. And there's approximately 400 different permutations of 20 people you can have in your room. The probability can get really kind of complicated. Okay? This is not an easy probability to explain in just a minute. But here's the deal. That's 2.4% in one class. If I go 2.4% in all of your classes, and there are roughly 90 classes to choose from, and you have 8 classes, you actually have roughly about a 6% chance of being in a class with somebody that has the COVID. So 6%, and you're like, well, that's not a big deal. Well, if you come, that's 6%, that's about 1 out of 16. So if you come to school for 2 weeks like that, it's almost a sure chance that in those 3 weeks, go to school for 3 weeks, and that's the numbers for 3 solid weeks. There's almost a sure chance that you're going to be in the same room with somebody that's positive with COVID and contagious at the same time. So that's why they do these soft closure kind of things. But ironically, you can still go to basketball games and play rehearsals and all that kind of fun things. So anyway, but that's a whole nother discussion, guys. But those things are all about probability. Now, practice set C, guys, is first part of your assignment tonight, and it's going to talk about exactly what we were talking about just a second ago, dependent probabilities. 2 probabilities, you're going to multiply them, but one affects the other. So think about the probability of the first thing that's happening, the probability of the second, assume the first one did, and then multiply them. Okay? Now, the other, set D, I think you're going to love set D. It's quick, it's short, it's easy, it focuses on Venn diagrams. okay? And it focuses on reading Venn diagrams. So let's think about this. If I have a Venn diagram here, I've got two situations. I got students and in a college math department. In this math department, I had male. How many students were male? Well, everybody in that circle was male. So that's 175 plus 50. That's 225 that are male. Whoa, I need to erase all that. And then these are the people that are working part-time. How many people are working part-time? Well, 75 plus these 50, that's 125. These 50, what are they? They're males. Yeah, they're males that are working part-time. They're both. And these 125, these are not males and not part-time. So these are girls that are not working. So when I'm talking about the probability of somebody being male, I got to figure out first how many are in the whole chart. So I add all these together. 175 plus 50, that makes 225 plus 75 makes 300 plus this. There are 425 total in that department. So if I'm asking what's the probability that they're male, well, it's out of 425, and we already talked, there's 175 plus 50. All of these guys are male, so that's 225 out of 425 that are male. Okay? So set D is all about using a Venn diagram to answer some probabilities. Okay? What's the probability they're not part-time? Well, if they're not part-time, I'm just going to start it off. It's out of the 425. If they're not part-time, they're not in that circle. Well, outside of that circle, the part-time circle, I've got this 175, but don't forget these guys that are outside of everything. 175 plus 125, 100 plus 100 is 200, 75 plus 25 is another 100. That's going to be 300. So 300 of those people are not part-time. Okay? This is all about reading the Venn diagram and finding the numbers. Probability of male and part-time, it's going to be over the whole chart again, so it's over 425. Okay? Where are the males and the part-times? Max said it. I think that was Max's voice that I heard. They're right here. They're these ones that are in the part-time circle and the male circle. These people that are in this crossover area, they're part of both groups. So there's 50 males that are part-time. Okay? But then we can get a little more creative with it. What's the probability they're part-time and not male? It's still over 425. Where are the people that are part-time and not male? How many of them are there? 75. They're in the part-time circle, but they're not in the male circle. So I'm ignoring these people and just looking. They're at 75. Okay? Last one. Probability of male, but not part-time. Well, I'm looking in the male circle, but they can't be part-time. So I'm going to cover up that circle now, and I'm just looking at the male. There's the 175. So set D is just going to focus on giving you, it's going to give you one Venn diagram, and it's going to ask some questions like this. Okay, guys, that's set C and D. Your practice work for tonight is set C and D. If you want to attempt quiz 4.1, all power to you. It's open and available. If you don't, when I see y'all, when I see y'all next time on Friday, actually, I'm not going to give you time because we don't have a full class. We only have 45 minutes. So quiz 1 and set C and D. If you haven't taken quiz 1 by the time I see y'all on Tuesday, we'll take it Tuesday in class. Okay, guys, that's what I got for you today. There's more resources online if you need a little extra help. I've got about 4 minutes left before I need to call it quits and get ready for the next class. In the next 4 or 5 minutes, are there any questions you